what geometry would be perfectly balanced in every possible way? This looks fairly balanced. This is Buckminster Fuller's isotropic vector metric. It's just not symmetrical because inside of those tetrahedrons, you have these cavities. So then if you take two of these structures and you push them together like this, then you have a star tetrahedron with a total of 40 tetrahedrons. And now you have a perfectly balanced geometry that's been formed on the inside of these two tetrahedrons, together called a star tetrahedron or a Merkaba. There's meditations related to this, and that's the reason for this is because this is the most seed fundamental code geometry of the structure of space-time itself. Inside of that star tetrahedron, you get this geometry in red. This is the only 3D geometry that has all the sides the same length, and the vectors that go from the center of the geometry to the edges are also the same size, the same length as all the edges. Every line in that geometry is the same length. That's why Buckminster Fuller called it the vector equilibrium. The geometry term for it is a cube octahedron. It's 8 tetrahedrons pointing in to a single point. So 12 around 1. You've probably heard of 12 around 1 before. Esoteric and non-esoteric. So here's the thing, though. What does that mean? That the universe is one gigantic cube octahedron? It's got to be fractal. It's got to be able to get bigger and bigger and bigger to the size of the multiverse, and smaller and smaller and smaller down to the size of the Planck length being the shortest possible measurable distance, because it's the diameter of the smallest possible photon of light. Thank you, Max Planck, for figuring this out. So from the Planck to the multiverse is a lot of orders of magnitude. So many orders of magnitude. So maybe it's cube octahedron inside of cube octahedron inside of cube octahedron, and it goes Russian dolls forever style, all the way down and all the way up. So let's start putting more tetrahedrons on the outside of this. What happens if you put 4 more tetrahedrons onto each point of a star tetrahedron? You get to a total of 64 tetrahedrons, and then you get to 2 octaves of this perfectly balanced geometry. It's a cube octahedron inside of a cube octahedron, perfectly balanced vector equilibrium inside of a perfectly balanced vector equilibrium. And that's the fewest number of tetrahedrons that you need to start to see this infinite fractal division of spacetime. Then it goes 512, it goes 124, 1024, and it goes infinite from there. Computer programmers in the audience are nodding their heads right now because this is the structure of memory in our computer systems. And it happens to be the geometry of a lot of things related to biology and ancient civilizations architecture and encoded, incredibly knowledgeable databases, things like the I Ching, the Bible, the Torah, the Quran, but we're going to get there. This is showing you that this geometry is a 3-dimensional structure. 8 star tetrahedrons put together gives you this 64 tetrahedron grid. The 7th one has a 1 behind it. This is kind of a computer animation of a 64 tetrahedron grid. You can think of it like music. You got an octave, and then you get to the next octave, 64, and the next octave, 512. Just like in music, you have a note, and you go up 7 notes, and when you get to the 8th note, just like the 8th star tetrahedron, you get the octave. So this is a octave relationship in the structure of space-time, analogous to the octavization of vibration and the string motion in music in a piano. We're using this geometry all the time in our daily lives, just through our music and through our visualizations that we're already starting to tap into, thanks to the esoteric traditions from thousands of years ago that have encoded this information all the way through the generations to where we are now. And so it's pretty cool that we've got it to the point now where we can do a seminar with all these luminaries from around the world. This is starting to become common knowledge. It wasn't common knowledge when I first came across it 21 years ago. And when I first started to do presentations on this, I got a lot of strange looks. But now people more nod at me instead of saying, that's strange. I thought that everything was the way I was taught in high school. But it turns out that a lot of the stuff that I was taught in high school is very incorrect, unbelievably so. I mean, just the fact that they showed me a picture of gravity like this with a ball and then the trampoline, right, where gravity's bending the space-time, but the space-time is not flat. This is showing you flat space-time. I know it's simplification, but I think the kids are ready to see 3D animations showing that space-time is actually curling and falling in every direction. So it's not just this fabric flattening of the space. And a black hole being this infinite curvature of space-time is not just some funnel that just disappears. So it's not that a black hole is a giant cosmic sized vacuum cleaner that sucks everything in and it disappears and goes to another dimension. A black hole is a three-dimensional object. It's not a funnel going to a point. It has an equal and opposite, and it's spinning like water going down the drain. When you pull the plug out of your bathtub, the water doesn't just go straight down, it spins because there's an energy density gradient, and the water and the air are different densities. And so they're trying to equalize. And when they pass by each other, they spin. The water spins down and the air spins up. This is what happens in all black holes as well. So energy is coming from both sides and then spinning out, and it forms a toroidal shape. So black holes, and this includes the atom, by the way, because Nassim Haramein's theory includes the fact that black holes are basically all there is, and that a proton is a black hole, and that there's a black hole in the center of every star, and there's a black hole in the center of every galaxy. And so it's scalar black holes all the way up and all the way down. And they're forming a dual torus shape where information goes in across the event horizon, which is the boundary condition around the singularity of the black hole, beyond which you can't escape, including light. That's why they call them the black holes. And the information goes in and it gets spun back out again. It doesn't just disappear. And then it goes back in and it goes back out. And so you get a closed loop system, and all the information that falls into a black hole gets encoded by the black hole. And you can see only the information on the event horizon. You can't see into the black hole. And so this is very important because this is just starting to describe not only cosmological black holes, but the black hole that is the proton. If the proton is a black hole, then there are tiny little quantum scale black holes rotating around each other at the speed of light inside of every atom, and you're made of quintillions of atoms. So we literally are beings of black holes. We are in the structure of space-time resonating with the information of the field of space-time itself. This is how information is exchanged across all scales. This is how the universe is keeping track of itself and not getting confused. We're confused. The universe is not confused. The universe is keeping its structure very, very organized, and it's not changing crazily over periods of time. It's staying together. The big stuff is made of small stuff. So anything cosmological size is actually made of atoms. Everything is connected literally by the structure of space. That is not an esoteric statement to say everything's connected or that we are all one, because there really is only one thing. It's space-time doing its thing. And it gets very, very chopped up. It gets very, let's say, it gets very isolated in some ways because space-time has its balance, and where there's an imbalance where you find a vortex because there's a density gradient in space-time from the cosmological scale down to the quantum scale. At every scale, space-time is spinning. So here's spinning space-time basically at a diameter of hundreds of kilometers, and here's spinning space-time at a diameter of tens of thousands of light years, and here's spinning space-time at the diameter of microns, the carbon particle. Space-time is doing this, and matter is doing this at all scales. And then nature is mimicking that field patterning. And you see it in things like plants and agave and shells and turbulence when you're flying in an airplane, and algae blooms off the coast of Ibiza, and the spiral arms of our galaxy. This is the old picture of our galaxy. Nassim Haramein liked to show in that movie Thrive by Foster Gamble that the galaxy is actually stars that go out towards the halo of the galaxy and come back in and then spin back out again. The sun takes about 250 million years to go around the galaxy. And so, because the sun is only around 4 billion, or the Earth is only 4 billion, but the sun is only about 20 galactic rotations old because it's 240 million for each rotation. Now, this is where Nassim is showing that all these toroidal structures are nested inside of each other, that the human heart has a toroidal energy field, and so does a star, and so does a galaxy, and so does the atom, that we are embedded in this spinning vortexes of space-time, spin inside of spin inside of spin. When I was a kid, they told me that the Earth was going around the sun in circles. And so I was imagining when I was 10 years old that I had gone 10 times like this. But that's not accurate. The sun is moving. And it took Nassim to be one of the very first, if not the first person to animate the solar system moving. This animation is nearly 20 years old, and he had to get the best animators around at the time to use the best computers available to make that animation. People have taken that animation and then improved upon it, but it's basically showing that the sun is moving through the galaxy as the galaxy rotates. The planets are spiraling around the sun as it moves. So every planet is making a helical structure, and each planet is making a different size helical structure because they have different orbits. And so here's kind of a 2.0 version of that. And I'm very much looking forward to the next level of this where you can just play with this and zoom in and out. If it doesn't exist already, I'm surprised. I just haven't dug in to find it yet. But you start looking at the geometry of motion and the geometry of our solar system over time, and you see that these fundamental geometries related to the platonic solids and the most foundational geometries you can make are starting to emerge just from the periodicity of things like Venus and Earth here. This is our more modern view of the galaxy that came out only, I don't know, a decade ago or something like this. NASA put it out, and it was pretty interesting to see that they're basically showing now that there are 50,000 light year emissions of gamma rays and X-rays coming out of the galactic center, forming a gigantic dual torus. I thought it was pretty cute. They used the same color that Nassim used for his animation. And isn't that awesome that your baby picture looks pretty much like the galaxy? We all started as a sphere, and when the egg got fertilized, boom, we're a dual torus, literally. Our physical beings were a dual torus, which matches the structure of black holes on all scales. Then our cells start to divide, and they don't just divide randomly with blobs of cells sticking off. There's a very specific geometry to our cells. When we get to be 8 cells old, we are a cuboctahedron. We are the vector equilibrium. We are the geometry of space-time itself at another fractal level. And then it goes on until we're 64 cells old. And not until after you get to be 64 cells old do your cells start to bifurcate, where one cell becomes a skin cell and one becomes a nerve cell, etc. This is very fundamental to the structure of biology as well as space-time. Here's showing the relationship between the star tetrahedron and putting a sphere around each one of those tetrahedrons. This is the important point, is that the sphere and the tetrahedron are the most fundamental relationship, like I was showing with the 19.47 degrees latitude with the pyramids. If you put a sphere around each tetrahedron in a 64 tetrahedron grid, then you get a 3D flower of life symbol. And this is the symbol that you've seen around the world. The nodal points of where these spirals overlap is giving you the points of the star tetrahedron. This is showing you the visualization of the spheres and the tetrahedrons together. Seed of life. This is the torus, the accretion disk of the information coming out mostly along the equator. That's why our galaxy has like a record, waves of stars. It's not flat. It's more like the surface of an LP vinyl record with grooves on it. because it's all cymatics. The entire universe is the structure of matter is basically the resonating of the structure of space-time. It's the cymatics of space-time, if you will, which is cymatics being the visualization of frequency or vibration. So biology is the feedback mechanism for the universe to learn more about itself. Where information comes into our consciousness, we are able to quickly assimilate and learn and gain new information and then change our environment. This is the universe being extending itself out to the very edge of what it can do and creating more coherency. So we are basically like antenna of information, and our codons of our DNA, and we have 64 of them just by coincidence, or maybe it's not, we are encoding this information that goes way back through time, where our ancestors have encoded experience into their DNA, genetic memory, biological memory, and it goes through generations. We've done tests and seen that trauma can be sensed by generations born 7 generations after the trauma, even though they never experienced the original source of the trauma. So it's a much more subtle and much more mysterious universe than the, let's say, traditional standard model physicists are talking about in universities right now. The C word is not the normal C word in physics. The C word in physics is consciousness. They do not want to say consciousness. As soon as you start talking consciousness in the context of physics, a half of the audience of physicists start to roll their eyes and they say, oh, well, that you can't quantify consciousness. So we're not going to go there because we need numbers, we need facts, we need data. We're not doing theology here. And so it's unfortunate because this dichotomy happened a long time ago, the separation of church and science. Science and church have been saying the same thing for a while now, but there's not a lot of people that are talking about the philosophical and religious and spiritual and the science at the same time. Fortunately for us today, we have those people on this multi talk panel of this epic series that we're doing here, basically tying together all these loose ends because there's all these different disciplines that have connected the dots, but now we need to connect those dots and create even more coherency and try to get our act together. If we don't get our act together, it's going to get pretty dramatic pretty quick. We know we're making mistakes in what we're doing. We're pulling structures out of the ground and putting it into the atmosphere that shouldn't be there. And we're changing our local environment rather quickly. Thankfully, we're starting to realize that and we're starting to make adjustments. But I feel like by us understanding the most foundational principles of nature and applying that to our physics, applying that to our methodologies across all disciplines, applying that to the way that we think about ourselves and our own personal disciplines that we do on a spiritual and even physical level with things like yoga and exercise, then we start tapping into the foundational structures of the universe, and hopefully we then learn to resonate and vibrate in coherence with the universe instead of pushing up against stuff, breaking stuff, trying to destroy things. We've seen a lot of folks get very confused because they've been told things that do not feel in alignment with what their actual day-to-day life experience is. They've got parents or religious figures or a guru or an organized religion or an organization or a corporation or a media outlet pumping people with information, being like, this is the deal, this is how things work. And then all these folks look and feel and go inward and they're like, that doesn't make any sense to me. It doesn't make sense because it doesn't, because they've decided to, take on ideas and thought forms that are not in alignment with nature and the way the universe is working. And that's why we're seeing such incoherence today and so many people making very misinformed decisions including things like my book says this and your book says that, and we're not happy. And so you've got this war happening in the Middle East right now. And gosh, I'm going to show you here in a little bit about how all this information is actually encoded deep into both traditions, the Islamic tradition and the Jewish tradition and the Christian tradition. And not only that, other more ancient civilizations prior to that. And the knowledge has been passed down. The knowledge of the structure of the universe being passed down into ancient civilizations and all the way through time to our generation now, into our biological structures, into our societal structures. Very fundamental ratios like the phi ratio is encoded in many different ways, in spirals, in branching, in the wake that I was showing you earlier. This is Rafael Araujo from Brazil, great artist, showing kind of the architecture underlying the spiral and the curve. The universe does not make tetrahedrons, it makes spheres. But if you pack spheres together perfectly and they overlap, the fundamental geometry that centers all those spheres is a tetrahedral geometry, which is the vector equilibrium. We're starting to realize we should probably learn from nature and employ some of the techniques that nature does, like putting our solar panel field in the shape of a spiral and a phi spiral, like a sunflower, because it's the most efficient way to get the most amount of light to the most surface. We're starting to do this also with CRISPR, editing genes and editing the DNA molecule, which has this very fundamental structure related to phi and the structure of space-time. And all these traditions in religion from thousands of years have encoded these same kinds of geometries. I really like this image because it's showing you very basic vibrating water with different frequencies of sound. Those are the cymatics images, cymoglyphs at the top. And then you have all these various mandala images from various religions, from Catholic, Aztec, Egyptian, Hindu, and then the CERN particle accelerator. And then you've got all these DNA molecules. Basically, just giving you that sense visually of how everything is connected through geometries, fundamental geometries that ancient civilizations have been aware of for thousands of years. These are 3,000-year-old Platonic solids found, I think, in Scotland. These are the Platonic solids. Take a sphere, you put spheres around, 6 of them, because that's how many fit around this one circle, and then you put another circle after that. You get a total of 13 circles, and you connect the center points of all those circles. It's called Metatron's cube, and you can get each of the Platonic solids emerging out of that structure: tetrahedron, octahedron, cube, icosahedron, and dodecahedron. And the dodecahedron is right at the right angle that if you put a cube inside there, it intersects with the points of the dodeca. So all these structures are actually related to each other and embedded. This is the first image ever taken of an individual molecule, and those hexagonal structures are individual atoms. We did this probably over a decade ago. This was done by IBM initially. Now we have electron microscopes and quantum microscopes that can see down to the atomic level. And we're starting to be able to build molecules. And we're starting to edit DNA with CRISPR. We're really starting to get down into the very basic fundamental properties of matter at the smallest scale. Things like probability patterns of where subatomic particles are going to be sitting.